Let's test a claim for a null hypothesis. Here we're given an abstract problem where we're looking at a proportion P of a population being 80% against an alternative hypothesis that this proportion of the population is greater than 80%. We're given a sample of 400, and it has shown that we get this sample proportion of 86%, 0.86. So we want to use a 5% level of significance in the p-value approach. So I always just like to say what my null and alternative hypotheses are, and in this problem they're actually just given to us. So null hypothesis that the proportion is 80%, alternative is that it's greater than 80%, and our level of significance is 0.05. And again, a lot of people kind of ask me, well, look, we got a sample proportion that's bigger than 80%, is 86. Isn't that enough to reject the null hypothesis? And it's not. The reason why is we have to see how significant is that result. If this had a likelihood of getting our proportion of 0.86 that was really, really small, less than 0.05 say, then we are going to in fact reject the null hypothesis in favor of the alternative. Otherwise, if it's fairly common, greater than 5% chance of us getting that sample proportion of 86, then we won't reject the null hypothesis. So we have to see how likely this is, and this is exactly what a p-value is. So first, before we get our p-value, we have to do a test statistic, and we don't have to memorize formulas for that. We go to our table, and for proportions, we have to verify NP and NQ are greater than 5. And what we'll do is we'll use z. It's p hat minus p divided by square root pq over n. So let's copy that down. Test statistic equals z equals p hat minus p divided by square root pq over n. And before we get too far ahead of ourselves, we ought to verify the hypothesis of this problem is true. So if we take NP 400 and multiply it by P, which is 80%, and NQ, which is N 400 times the complement, 20%, we should verify that each of these are larger than or equal to 5. And on my calculator, if I take 400 and multiply it by 0.8, I get 320. And when I multiply 400 by 0.20, I get 80. Both of these are greater than or equal to 5, and so we can use our test statistic. We have all the numbers that we need to plug in. P hat was our 86%. P, the original proportion, we're assuming is 80%. We divide by square root PQ over N, so I want to use my original P, which is 0.80. The complement to that is 0.20. We should always use the original P and Q in this formula as long as the original P is given. So be careful of that on your exam. And then we're going to divide by N, which was 400. And again, I would be really careful with rounding. So do the numerator, which you can probably see is about 0.06, then do the denominator and divide the totals. Only round in the final step. So here, what I would do is multiply 0.80 by 0.20 on your calculator, get that answer, and divide by 400. Then take the square root. So take 0.06, which is your answer on top, divided by that. And when I do all of this, and you should verify this, calculator is very important how you compute things, make sure that you get the same answer as I do, I get a z value of exactly 3. So what I can do now, finally, is get my p-value. So the p-value is the probability that we get as an answer as extreme as our sample. This is a one-tailed test, so it's just the probability in this case that z is, say, greater than or equal to 3. Remember, two-tailed test you double. One-tailed test you don't. So on our z table, let's look up 3.00. 3.00 gives us 0.9987. But remember, that's always the area to the left, so we have to subtract from 1 in order to get the area in the right. So let's take our 0.9987, subtract it from 1, and get our answer, which is 0.0013. So the probability based on the original hypothesis of us getting a sample proportion of 0.86 is 0.0013. Since the p-value is less than the level of significance, we reject the null hypothesis. Since p-value less than alpha, we reject H0 in favor of the alternative. In other words, at the 5% level of significance, there's sufficient evidence to conclude that the true population proportion is greater than 80%.